Welcome back, everyone. It's Sean from Having Fun Repairs. SounDigital EvoX2. I think I've had one of these before on my channel. 1200.4 EvoX2. Let's see, four channels. Yep, we got 4 inputs, 4 outputs. 300 watts RMS at 2 ohms, or you could do a bridge configuration, 600 watt RMS at 4 ohms. Okay, cool. I don't know the condition of this one, to be honest. I think he said, my local customer said there was a channel that was out. But I'll tell you what, we're going to power it up and just see what it does at power up first. Let's get the power supply going on this one. Make sure that nothing's touching here. Get that up all the way up to 12. And I've got it pretty current limited right now. I think right there will be good. I'll leave it there. I want to make sure that we are 12 across the post, and we are. Cool. All right, I'm going to turn on my SIGGEN. It's currently set for 1 volt. I'll take it up to 2. If I see 2 volts, I know that that's coming in. And it is. Okay, now I don't know what this thing's going to do when it kicks on, so I got to keep my eye on the current as I increase the REM and see what happens. All right, 7 volts, we're on, up at 8. I got a blue light. We're drawing only 0.6 of an amp. 10 volts on the REM, 12 volts on here, not too current level, 0.6. Well, that seems kind of low, to be honest. Maybe there is a channel out. All right, so everything's powering up. I'm not seeing like 3 or 4 amps or something astronomically crazy though, so that's good. We don't have a power supply issue. This is most likely, if there's an issue, it's going to be at the output with amplification. So I'll tell you what, I'm going to hook up audio source into it, and we'll probe the outputs. All necessary connections pretty much made at channel 1. I am going to, what am I going to put in? Go to, excuse me, channel 2. 80 hertz signal at 1 volt peak to peak. Turn that on. Okay, now I've got all my presettings. Let's see, I've got the LPF, the high pass, low pass filters. There's a center setting for full, so basically it's like a bypass. So we got both channel 1, channel 2, channel 3, channel 4. LPS set exactly the same. Or bandpass filters, because that's technically what it is at this point, I believe. I got channel 1, channel 2, and channel 3, channel 4 gain approximately the same. They were fully counterclockwise, and then I turned it up about a quarter of a turn. And then I got both crossovers set to 80, so everything should be relatively close. Looking on the back now, not sure which ones are channel 1, channel 2, so we're just going to probe right now. Yeah, so I'm not seeing anything. Let me turn it up just a smidge more. Make it to about halfway on both. And let's see, any change. So I'm not really seeing anything on channel 1. Let me make sure. Do I have audio coming out? Yeah, you can see it right there. It's incredibly low amplitude right now. Let me go up to channel 2 Nothing at the output of channel 2. Let's go to channel 3. I see nothing on channel 3. And let's go to channel 4. Nothing on channel 4. And just to make sure I'm not going crazy, I'm going to put everything to a low pass filter setting. And look back again on 4. Got to show up somewhere on here. Nothing. Alright, so I'm going to go through with everything on a low pass and then the high pass filter and check all the outputs again, but I believe this one is just no output. I've got the amp broken down, and it only took me about 2 seconds to, really not long, 2 seconds, I'm being a bit facetious, but just a few seconds to realize, uh-oh, Houston, I think we found at least one of the problems. Let me try to demonstrate it. Just going to swab inside here. What do you see there on the cotton bud? Oh, you see what I see. You see a carbon has deposited on the PCB. And hold on 1 second. I'll just throw the microscope into the mix and we'll take a look at a few things. Come with me and you'll be in the world of pure carnage demonstrated. Oh yeah. Oh yeah. Tasty bits. We now know why we don't have an output. Really hope those tantalum caps and those ICs are okay. But the MOSFETs, cooked. Yeah, they all look pretty cooked. Yikes. Those two definitely. That one not so much, but down there across the side, get all the way into it. I mean, we're not getting output either way. That doesn't look good. Yeah, I do really hope these tantalum caps are fine. Alright, so I need to get this board out and you start replacing some parts. Let's get a touch of cleanup done here. Now that I've got it desoldered from the board. Our pads are looking pretty good after desoldering them. Let's see, up here, I don't see any components. Well, hopefully that's not a crack. Okay, no, that's not a crack. That's else. Diodes there. I'm hoping these RS 2052s are good. All right, I'm gonna switch out the cotton bud for a second. Top wise, those two MOSFETs in there don't look too bad. We begin to see carbon, not from these two, but it gets worse as we go across. So hoping that all this can just be cleaned up. carbon is slightly conductive, hence why resistors and stuff were made out of them. So now we can see that it's get worse through here. That's cleaning up nicely. Rid of all this carbon. It's deposited all throughout here. Losing portions of that MOSFET that's blown. Okay. Those are probably going to be fused to the board when I go to remove them. I was really worried about this. I'm wondering if these are bootstrap capacitors close by to the MOSFET. Hopefully they're good. Obviously the value is unknown, but we got several in which we could close by get a value off of. Other RS2052. Okay, let's check it with a multimeter. All right, let's go over what we should see on these MOSFETs here. If I come across this pin over here, notice how there's a little pin out to the left. You can see it there up here at the top. Red probe's going to go on this side closest to that pin. 3 of these will be connected together, probably gate, source, drain, or something like that. I'd have to get the actual part configuration to tell you, but from across on the first 3, we should have a voltage drop of 0.5 all the way down, and including the third one. The last one should be somewhere about double to 3 times that amount. 1.8, 1.8, 1.8. You can see it all there. All right, so I need to do the same thing for that. Caps I'm probably going to have to remove, but you get the gist of how I'm going to test these. And obviously, if something's broken, we'll work on replacing it next. All right, looking over the board and testing with the multimeter, all of our other MOSFETs and those capacitors. I removed that one there and that one there and did a comparison, i.e. this guy and that guy, and they're both 1 microfarad capacitors, essentially what they came out to. But we are missing another component outside of these MOSFETs being bad, these 2. You notice there is a resistor missing from these 2 pads here. You see it located right there. Same as if you saw it right there. And moving all the way across to the other side of the board, you would see it right there. All right, so the question is, why's my, maybe it wasn't hung up. The question is what is the value? And I think it's a 1K resistor, at least in circuit. Here to measure this one. Comes out to 99, 100K comes out to 99K ohms, 98.9. Over here, same value, 98.3. My assumption is 100K ohm resistor. I'm going to heat up this board and try to remove these MOSFETs, and I have to remove one of these resistors and measure outside of circuit as well, for posterity's sake, and because this may end up helping somebody else. Let's talk about the amount of trace repair that needs to happen here for a second. so we'll move this MOSFET out of the way. Okay, this pad, it doesn't look bad. We've got some minor damage to trace there, but nothing completely blown out. You see that this whole area, including these little side posts, are all connected to the backside here. These three are connected, that one's separate, obviously, because you'll have gain, source, and drain, right? So this backside here is it's one thing, okay? All this right here, fine. Ooh, I wouldn't call it fine. As far as physical damage goes, it's, you know, it's a mess, but that's doable. I can lay a you know, MOSFET on, and it's still going to make connection with everything it needs to make to, because there's enough intact here. But you can see where the MOSFET blew out, and completely destroyed, where these three leads would have gone, and then this one right here, the separate, is fully missing. Two issues with that. One, because on the third leg, this one right here, we would expect, if I'll scoot over so we can look at another one. Third leg, we would have a resistor. That resistor goes over to this side right there. It is a 100 kilo ohm resistor. So you can see that the pad is missing for the resistor. And as I was cleaning, the pad went missing for that one lead on the MOSFET. Keep in mind, these three, 1, 2, 3, will be connected. This one does not. Then we have two other traces that are a little bit of a concern here. Okay, so where the, let's see if I can get this angled a little bit. All right. So you can clearly see right here, this is where the trace comes down and hits this. And then you'd also have that little resistor sitting right in there. That trace follows through and touches this resistor right here. Okay. So I'll need to do a jumper wire once I get the MOSFET in to this leg. And we'll also have to find a way to get that resistor in. Additionally, there's this small little trace you see right here, and now it's not connected to the back, but that goes through, and it actually goes up to the same circuit path as, well, you can kind of see the trace coming through the other side right here. You can see that it hits this tantalum capacitor right there. So I'll need to do a bodge wire to that as well. However, this actually connects with these three over here, with this pad being fully separate. So that has to connect to this side. This has to be fully separate, not connected to that side or this little thing up there. Need a little pad right here to go through and touch this resistor over there, and that would hopefully complete the entire circuit path. So again, like I said, for posterity reason, you can take a multimeter, you can figure this out yourself, just putting in continuity and comparing with other good components on the board, but that's where they're connecting. So as it stands, well, unfortunately, this is microscopic. I mean, you're seeing the tip of my, you know, tweezers right here. Now it looks big, and these components look big, but they're not big at all, and we've got to replace those traces. Okay, not big one at all. I mean, with my my camera out of the way for a second, and let me just turn this off. We'll get this out of the way. Okay. I mean, you can see there goes my needle nose pliers. Maybe you can make out the tip right there, but yeah, so lots and lots of very tiny work we've got to do to get this hopefully working again. I went ahead behind all the porting and kind of patched up the PCB a bit with some conformal coating. I have to get a strip of copper down in this area as well. But mostly so I can get these pads to kind of stay in place. This one, and you know, we'll have to make these reconnections where they need to go. But that being said, everything is in place. We could probably start getting components on there. I just need to test, make sure that I'm not getting continuity between this and the backside of the metal side of this board, because it kind of acts as a heat sink, but you don't want to short out anything. So underneath this is just that aluminum plate, and you can short out these pads to it if you're not careful. I'm just making sure that there's no continuity in it and the metal plate, and not seeing any there on the multimeter. Okay, so at this point I want to get the components soldered in. Well, get a little strip of copper material down in here, because we're going to solder in that 0402 100k ohm SMD resistor. Got one right there, and we'll get those two MOSFETs soldered in, and then from there jump over the appropriate pads that need to get over to here as well. So I'm gonna get all that taken care of. Repair first power up. Got my benchtop power supply on. Set it up to 12 volts. It's not pulling any amps right now because I haven't triggered the REM, which is good. Make sure I'm seeing 12 volts across these terminals, and I am. Alright, so let me change the waveform of my channel 1 DC waveform. Turn it on and slowly start taking it up. Alright, we got power up to 10 volts. I'm seeing 0.5 amps drawing from here. There goes to 10. Might be a offset voltage right there. Not too sure. Either way, I think we're going to be okay to hook up an O-scope, see if we get and inject some tones to see if we get audio out now. So let me get all that stuff hooked up. Give me a second. All right, I've got an 80 hertz tone at 1 volt peak to peak coming in, and let's check the output. And no, we've still got some switching issues here. Let me look at the input. Yeah, we've got an 80 hertz tone at the input of channel 1. Nothing on the output still, so that might be the driver ICs. Those MOSFETs did test okay. Here's the input for channel 2. Yeah, we can see it there. Let's look at the output. Yeah, driver ICs are bad there. Okay, let's look at channel 3. No, where's 3 show up at? Is it here? Yeah, 3 is right there. Yeah, alright. So, channel 3 is not good. And let me look at channel 4. There, and anything out of channel 4. It's even deader. Okay, so it's looking like the driver ICs have to be replaced as well. Well, I've got the IRS. What are these? So tiny. I even have the thing out there. No, here goes the package. Let me pull it out my trash bin. I didn't record this because it's so mundane. Maybe not mundane for people. It's a pain in the butt to record those ICs going in. Part number IRS 2052, Mike Tango Romeo Papa Bravo Foxtrot. There you go. Because they're not ball grid array, which I think might actually would have been easier. You can see that there are little feet. Maybe not the best viewpoint from up there. But it's just kind of a pain to get those soldered in. I do it under a microscope. It's very time consuming. So I didn't record it. I just wanted to get those in. But I do now believe we can test our inputs and see if we got any outputs now. So I've got an 80 hertz tone being generated from my signal generator, and we'll come in and we'll check channel 1, channel 2, channel 3, and channel 4 with the oscope. All right, so 80 hertz tone in at 1 volt peak to peak, and let's look at channel 1. Hey, there we go. 64 volts at 80 hertz out there on channel 1. Let's go to channel 2. Come on out there. There we go. So channel 2, 61, 62. So I mean, there's only one gain adjustment for channel 1 and channel 2. I would say that those are pretty close in amplitude. Nice sinusoids sitting there at the output. Channel 3, 69, 70 volts peak to peak. Okay, so we'll go to channel 4. And yeah, 72. Slightly higher, I guess, because of the adjustment I have right there. Anyway, yeah, so we got outputs now. So all I really need to do is clean up this and button it up and get it back to the customer. I believe they're going to be happy. Cool. All right. Well, if you enjoyed this video, again, apologies. Maybe I should have recorded putting in those ICs. But if you enjoyed this video, let me know. At least now you know what MOSFETs to use with those 2052 amps in this design. You were able to get the amp fully repaired, which is good. It's drawing 0.9, almost an amp from the power supply I have here. Benchtop power supply, 12 volts. Anyways, digressing. Yeah, we were able to get it repaired, and I'm pretty sure I'm going to have a very happy customer. So if you enjoyed this video, let me know by leaving a comment in the description. You're always welcome to subscribe. I've got a lot of people who watch this channel who are not subscribers. So, hey, you're already here. You might as well hit that sub button. All that being said, thank you for spending your time with me over the repair of this SounDigital 12.4 EvoX2 amp. Take care and goodbye. Bark.